Viewers, today our topic is the property of a free gyroscope. Remember, last topic we already discussed the spin, tilt and drift. So today we will discuss about the properties of a free gyroscope. Guys, there are two properties of a free gyroscope. One is gyroscopic inertia, another is the precision. Guys, the gyroscopic inertia or the rigidity in space, this is the ability to pointing in a fixed direction without applying the external force. Remember, this in the first principle there is no force, okay, and second principle we will see there is external force. Guys, the rigidity in space means when you pointing a spin axis to a fixed direction, it will continue pointing towards that direction until you applied any force. Okay, like this is the rotor and it's rotating, and this is the spin axis and it's pointing to a fixed direction. Until applying any external force on this rotor, it will pointing towards that fixed direction. So for gyrocompass, it is a pole star, we call it pole star or the gyrostar, which is near the north pole. So once it pointing to the north pole, means the north star or the gyrostar or the pole star, as when it's spinning it will pointing in that direction, and until applying any external force it will continue pointing to that direction. This is the rigidity in space or the gyroscopic inertia. Guys, this come from the Newton's law, rigidity law. There is the ability to point in a fixed direction without applying any external force. So viewers, this gyroscopic inertia or rigidity in space, it depends on three factors, that is the mass of the rotor, mass distribution of that rotor, and the rotor speed. Okay, this is very important, guys, because of if the rotor mass is more, then more rigidity to space. Remember, okay, so gyroscopic inertia is proportional to the mass of the rotor. So more mass, more inertia, more rigidity to space. Remember, okay, and another is the mass distribution. Like this is the rotor, okay, this is the center, okay, and this is the periphery. Okay, guys, so if the center is light and periphery is more weight, like periphery is more weight, guys, if the center is the lightweight and the periphery is more weight, so it will give the more rigidity. Okay, and again I draw a rotor, this is the center. If the center is more weight and periphery is the lightweight, then it will give the less inertia. Okay, so this mass distribution is very important thing. So which rotor has the periphery has the more weight and center is the lightweight, that has the more inertia. Okay, remember this one. And another is the rotor speed. So more speed, more rigidity to space. Remember, guys, more speed, more rigidity to space. So rotor has the more speed and pointing in a fixed direction, so more speed, more rigidity. Remember, okay, so that's why the rotor must rotate at a constant and high speed, that is can be more than 20,000 rpm or more. It can be the rpm for the gyrocompass. It can be the makers to makers, can be vary, guys, that one we will see after that, guys. Okay, so remember these three factors is depends on the gyroscopic inertia. That is very important things, remember. Okay, so gyroscopic inertia is the rigidity in space. This is the ability to point in a fixed direction, and it will pointing in that direction until any external force is applied. Okay, remember, so if you don't apply any external force, it will pointing to that direction. But guys, due to the earth rotation, there is the tilt, there is the drift. So tilt and drift is the external force here. Okay, and that tilt and drift come from the earth rotation. Okay, so guys, I think you understand the gyroscopic inertia. Again, I'm saying, just listen, guys, this is the rigidity in space. If we can rotate the rotor in a certain speed, and if there is no external torque or force applied, firstly it will pointing in a direction and it will continue pointing on that direction, towards that direction, remember, until applied any external force. Guys, remember, in gyrocompass we will call the force means the torque. Okay, so until any external torque applied, it will pointing to that same direction. This is the gyroscopic inertia. Okay, and guys, the precision is the movement under applied torque. Like when a free gyroscope is rotating, so if there is any torque or any force, what will be its behavior? That is the precision, guys. Okay, so when it's moving, so when a torque is applied, the gyrocompass axis move right angles to the applied torque. Okay, so you will get the precision, and precision will be 90° with the torque. Okay, so we'll see some figure. Remember guys, this precision is, I'm telling you again, when a torque is applied, when rotor is rotating, behavior of its movement under a applied torque. So precision is perpendicular with the applied torque, so depends on which side the rotor is rotating, and precision you will get 90° away from the applied torque. Okay, like precision, okay, this is the rotor and this is the applied torque, and precision will be 90° with the applied torque, and it will be towards the rotation. Okay, remember, so this is the rotor and this is rotor is rotating like this, and this is the applied torque, and this precision will be like this with the applied torque. Okay, understand guys, like this, and this is clockwise rotating, and this one, this rotor is anti-clockwise rotating, and if this is the applied torque, and the precision will be 90° with the applied torque this way. I think you understand this one. Okay, 90° with the applied torque and towards the rotation, remember. Okay, so this is the applied torque. Okay, so this rotor is rotating clockwise, so precision will be 90° away from the applied torque and towards the rotation. You see, so rotation is like this, so towards the rotation, you understand, like this. Okay, you can imagine this one like this way. Okay, that's like rotation is this way. Okay, precision is this way. Guys, this is the torque, this is the rotation, and this is the precision. This is the torque, this is the rotation, and this is the precision. Okay, so remember, this precision is this one, that under the applied force or under the applied torque, how a gyroscope behave. So viewers, for more figure, if I explain this one for the precision, is same things guys. This is the applied torque. Okay, and this precision will be 90° with the applied torque and towards the rotation. You see, this side is the applied torque and this side is the precision, just 90° with the applied torque. This side is the torque and this is the rotation, so this side is the precision, 90° with the applied torque. And guys, this one you can see, this is the torque and this is the precision, so precision is 90° with the applied torque and towards the direction of the rotor. Okay guys, this is the second property of a free gyroscope, that the precision, and this is the meaning of that under the applied torque how a rotor behave. Okay, so gyroscopic inertia is the rigidity in space just to pointing in a fixed direction without applied any external torque. Okay, and precision under the applied torque, what will be the behavior of the rotor? This is the precision guys. Okay, so I think you understand this two property guys, and I already explained to you that gyroscopic inertia depends on these three factors. Okay, and this is the movement of the precision guys under the applied torque. Okay, I think you understand this one. So next class we will go furthermore guys. Okay,